Alright, so hello and welcome. Working on another problem. This is the Skyline problem. This I haven't seen before, so we'll see how this one goes. Okay, so Skyline problem. Let's get it going. Skyline problem. The city skyline is the outer contour of the silhouette formed by all the buildings in that city when viewed from a distance. Given the locations and heights of all the buildings, return the skyline formed by these buildings collectively. Oh, I see. So when you look from a distance, there's like a skyline. Geometric information of each building is given in the array buildings, where buildings of I is left of I, right of I, height of I. What is the left and right of I? Left is the x-coordinate of the left edge of the ith building. Oh, I see. I is the right of I is the x-coordinate of the right edge of the building. Height of I is the height of the ith building. May assume all buildings are perfect rectangles, grounded on an absolutely flat surface at height 0. Okay, skyline should be represented as a list of key points sorted by their x-coordinate in the form x sub 1, y sub 1, x sub 2, y sub 2, dot, dot, dot. Each key point is the left endpoint of some horizontal segment in the skyline except the last point in the list, which always has a y-coordinate 0, and is used to mark the skyline's termination where the rightmost building ends. Any ground between the, okay, they kind of lost me. Any ground between the leftmost and rightmost buildings should be part of the skyline's contour. Excuse me. What? I'm not really sure I understand. I think I have to read the question a few times and take a look at some of the solutions. Get skyline. Okay. We'll just call these B's. Or B, buildings. Build. I was going to call it BS for buildings, but I don't like to use BS as a variable name. Okay. There must be no consecutive horizontal lines. Oh, I see what's going on. Oh, that helps a lot. That. Excuse me, that helps a lot to explain what's going on here. Must be no consecutive horizontal lines of equal height in the output skyline. For instance, 2, 3, 4, 5, 7, 5, 11, 5, 12, 7 is not acceptable. The 3 lines of height 5 should be merged into one in the final output, such as such 2, 3, 4, 5, 12, 7. So 2, 3 would be like 2, 3, 4, 5. 4, 5 like this. And then 7, 5 would be like this one, so the horizontal line. And then back down to, and then 11, 5, and then 12, 7 goes up higher again. So they're saying it should be merged. This 7 and 11 should just be 4, 5, 7, 5, 11, 5 should be 4, 5, and then 12, 7. Yeah, I see. Because then we just assume. This is really confusing. Got a lot of outputs, but it's confusing, this part, because I mean, we could just like loop over the array at the end and just merge the intervals. Basically everything that has the same y coordinate, we just eliminate all the other ones to the right. Excuse me, but it's effectively different heights. That's kind of the deal. So like you see this new height to the right, then you assume that there's this connecting piece. You see that? There's sort of a right and down, right and down, right and up, right and down, right and down. You could just assume you don't need to have all those edges in between. Yeah, I mean you could generate those anyway. The only one you don't want to generate first, I guess, is just the initial point. Excuse me. Yeah, so you could generate the horizontal points and then just pull them out afterwards. Horizontal pieces, and then also the initial piece, I think, is the one you could want to remove. And how are the rectangles? So there's a left, a right, and then the height. Left x, right x, and a height. Okay, so basically I want to merge all of these rectangles to get you the skyline. Huh. A shows the buildings of the input. B shows the skyline formed by those buildings. Red points in figure B represent the key points in the output list. Okay. So 0, 2, 2, 5, 3. So 0, 2, 3, 2, 5, 3. Excuse me, 0, 2, 3. 0, 2 of height 3. And then there's 2, 5 of height 3. And so you could have all the outline of the points. But you want to remove the horizontal ones. And so yeah, you would have one point here. I don't know, kind of. You'd have like 1 point, 1 point. So you'd have 1 point. So these would be all the points. These are like all the points generally. And then you would say eliminate the horizontal ones, and then also eliminate the first one. And so then you'd have 1, 2, 3, 4, right? And so each time you have kind of like the first one, you have an initial starting point, and then you have these L shapes, right? This L shape, this L shape, this L shape, and you can kind of assume those L shapes. Right, so that saves a little bit on memory if you do it that way. 2, 9, 10, 3, 7, 15. Yeah, so that's kind of neat. So what's interesting about this though is like, I don't know, it's like this is probably very, very similar to like the histogram problems that we saw already, where you're not trying to calculate the area, but now you're trying to calculate like what the height is at a particular point. The reason why I'm going through this kind of explanation is that it's probably easier to just generate all the points of the contour first, and then you could update the what they expect. So I don't know what's we have some examples we can go through. So how much time we have? 9 minutes. All right. So this could take me a while if we ever get through it. I don't know. Each of the rectangles. Yeah, because there's some overlap. Like, so how would you take some rectangles and overlap them? What would be the correct way to do that? So I think using a stack is probably the way to go, because you can do something like you kind of read from left to right, and basically, I think what you'd want to do is you'd want to dump all of the points that you're gonna operate on into, from left to right, into a sorted list. A sorted list of points. And you want to process these points, right? So left to right in sorted order. Each I guess it would be each value of x. So each x value. So the left and the right points you want to kind of sort in that list. Process those events, quote unquote, left to right, each x value. But you also need to know whether it's the beginning of an ending or an ending, and of which building too. And you could use, I mean, we don't need to do this in linear time. This could be n log n time. That's fine too. What are the constraints on this problem, by the way? I think n log n is fine. It's probably what we'll end up using. 10 to the 4th. Okay. Not that many buildings. Buildings is sorted by left I in non-decreasing order. Left of I. So it starts off sorted. So we don't necessarily need to use sorting, but I think it's a little bit easier if we sort things. So what you can do is at each position x, you want to update like your state. So when you get a new building, you can put into your sorted set the height, right? So now this is the height, and you would take the highest height at each point, and so now you would create this new point. So you actually don't need this initial point, this one, so we don't have to do that. We could just add the highest point here initially when we add a new x coordinate. Then we process this next left side. We had a new height, right? We could take our set's highest height in the set. Now the tricky thing here is a couple things. We probably want a multi-set, because you could have multiple buildings of the same height. So we'd want a multi-set, the highest value in the multi-set of heights. And we also need to know, when we process left to right, if it's the beginning or the ending. So we could dump a Boolean, like we could dump a tuple, like dump all of the x coordinates into a tuple that has Booleans in there. So the Boolean 0 would be the left side and 1 would be the right side. And we could just have the x coordinates and sort that. And also have left, right, and I guess you could also have the height too. I guess it doesn't really matter. So you get a tuple of the x coordinate if it's the left or right of the building, and in the height of the building that's being added or removed. And then we have a multi-set of heights. So when we add a new building, we add that height to that multi-set. And then when we remove a building, remove that height from the multi-set. And then each time you process an event, you would take the highest height in that set, and that would be your next point. So here you go, we add the point here. Then we say, right, this height is removed. So you remove or add a height before you take the highest value, by the way. I think that's actually tricky. That's a question. So there's actually 2 points here, right? There's potentially 2 points to consider. So I think what we'd want to do is actually add the height first, if there is a height to add. So we'd want to check if it's adding or removing. If it's adding, we want to add the height first, and then get our value. And then also, if we're removing, that could be the highest height that we remove, and we want to check before we remove the height. So we want to check after adding the height and before removing the height, depending on which one, if you're adding or removing, which case. Yeah, because you could remove a height and it doesn't matter, or you could be removing the highest height, but you want to check the highest height. And then here, so you would process the next event, add this highest height. So oh, whoops, I forgot to, there's actually a couple in between. So here you would have a horizontal, even though you removed. Here you remove again. And then, and actually, if it's horizontal, I think we can remove it. So if it's meaning, no, you don't know yet. Actually, you actually don't know yet. So you have to remove these later, pull these out later. I think that's fine. And there should be an initial height of 0 also in the multi-set. There's just always a 0 in there for when we remove. No, the heights of the buildings are not going to be 0, right? Yeah. Okay. So we could just have a 0 that sits in there, stays in there. Actually, I think it's a relatively easy question. So then we just process the array again at the end and remove anything that's like the extra horizontals in between. Now, how do we know if something is an extra horizontal? That's a good question. So these are kind of a question of what to do about these. But otherwise, our algorithm will give us what we want, as described. Yeah, we always have an extra height in the beginning, so that way when we lose. So yeah, so that's kind of it. So we have a multi-set. We have a ordered vector of tuples, right, which is going to be the x value, whether it's a left or right, and the height that's being added or removed. Multi-set of heights with an extra 0 in the beginning. And we have a return vector of, it's going to be, if we're adding a height, we're going to add to the multi-set first and then check the highest value in the multi-set. If we're removing a height, we're going to check the multi-set. If we're adding a height, we're going to add the height first and then check. If we're removing a height, we're going to check first and then remove the height. And then when we're done processing all these points, right, the x-coordinate and the associated height, that vector of tuples, we're then going to process that again and say, basically, there's like a merge interval routine that we had previously where we want to merge all of the points. It's not the points of the same y-coordinate. It's the points that are between 2 points of the same y-coordinate. So if you notice before, the 4, 5, and 12, 7, right? Oh, actually, yeah, we do want to merge the horizontal parts. I'm wrong about that. Yeah, so... Oh, no. Yeah, this won't even exist at this point. So actually, this is kind of interesting. So you don't want this one. You do actually want to remove the height first. I'm sorry. I was wrong about that. You do want to remove the height first. Yeah, so yeah, you add or remove the height first. And then I think if the height doesn't change from the previous value, then you don't add the point as well. So we could do it that way. So the height didn't change. We don't do that. We don't add it. Height, the height, when we added a new height, it did change. So we add this point. We add this height. The height didn't change. We add this height. The height didn't change. The previous height. We remove this point. The height did change. That's when we add this guy. And then we remove again. The height did change. We add this guy. I think we could do it that way. Only if the height changes. So we add a point. Yeah. And for the previous height. Yeah. I think that's fine. So set the previous height to 0. We get a height change initially. Yeah. So we can do it that way. So actually, yeah, we do want to add or remove before we process, and then we also have a previous height. So that way, that allows us to get the points we need. I think that works nicely. So we can do it this way. Where are we at? 20 minutes? Yeah. Okay. Sure. So let's take that. So let's try to use. Oh, okay. So this is like the simplest way to do it. There's probably a way. There's probably another way to do this that's a little bit more efficient, probably using stacks. But I think this is like the simplest way to think about it. Yeah, because we could pop these other values off. With a multi-set, it's very easy to just remove them or add them, and they won't affect what's at the top. So we'll use a multi-set for this. And tuples. So we're going to create tuples of x coordinates, booleans, to determine whether this tuple is the beginning or the ending of a building. And finally, int height values to know which heights being added or removed from consideration. So we have a vector of tuples of, and we're going to call them events. So we're going to have int, bool, int, event, a vector of events. We're going to say, just call, it's really like a queue, or just v. We're going to say, create a multi-set, store the height, status, height status, skyline, and insert a default initial value, 0 for the ground. So we'll say standard multi-set of ints, and this is going to be ms or just skyline, and we're going to say skyline.insert 0, and we're going to create our vector, or we're going to add events to our vector. We're going to say for const int x in the build. We're going to say const int a equals x of 0, or we'll say L R x of 1, and finally L, R, and the height, H, x of 2. And we're going to say there's 2 events that we add to our vector. Now we could actually sort, we could do both things. I mean, we could insert these events into the vector and then sort the vector, or we can make the vector itself a set and then process the set left to right. I think it's easier to just create a vector and sort it. It's simpler. So event E or E1 equals standard make tuple of, we said, so left, the Boolean is, so we're adding or removing. So true is going to be, so add building, const bool add building equals true, remove building equals false. So we're going to say add building, as long as these match up. This could be like an enum, but I think it's simply just use booleans. So left add building with the height and push back E1, and then same deal, E2 is removing the building on the right side, remove building height E2, standard sort on the following, so it's going to be v begin, v.end, and we're going to just take, it's going to be const event E1 to const event E2, and we're going to say return E1, so standard get, so we can actually put this on a new line too. 0 of the event is less than standard get 1 or 0 of E2. Right, so this will, this gives us a lambda expression that returns, basically, so this will sort events by the x coordinate. We have a standard vector of return values, ret, process event array, 1 by 1. So we have our return array, and now we're going to process. We're going to say for, really this could just be const event reference E in the events and V, and we're going to say, actually you could even do better than that. You could destructure. So the event is X. We could say add or remove, or B, we can call it, for the Boolean, or which kind of event, or type maybe is better. X coordinate, the type of event, and then the height in V. And now we say add or remove the building from the skyline first. So if type is equal to add building, then we say skyline dot insert height, else if type is, can really only be one or the other, remove building, skyline dot remove h, int previous height is 0. Okay, and now we say find the current maximum height skyline. So we're going to say max height. That's going to be the skyline. Really, it's dot end minus 1. This is the largest, or you could do the other way around. You could do skyline dot reverse begin dereferenced. So there's always going to be, given the format, we can guarantee there will always be at least one value skyline set. So you have the max height. We say if max height is not equal to previous height, then we're gonna update our previous height to the max height. And we're gonna process, only process changes in height. So previous height, and then updates to max height. And we're going to say ret dot push back a new vector that is of ints, and that's going to be created using, it's the x coordinate, so we have a new height, or max height, so we'll just say max height. It's going to be the height, it's max height, and it's going to be the x coordinate that we're looking at, which is x. So that's what we push back into our return vector, and then we return at the end. And I think it's that simple. I think it may be that simple. Something like this. Multi-set not found, not found. What? Multi-set. Set. Oh, okay. Okay, fair enough. Fair enough. Something like this ought to work. Oh, I see. Okay. Const auto reference B in building. And we can say, or X in building. Oh yeah, I don't know why I did that wrong before. Remove and multi-set. Okay. How are we doing on time? 30 minutes? Okay. Erase. Element at position, moves the elements in the range, moves all elements with a key equivalent to key. Ooh. All elements with key that compares equivalent to X. No. I only want to remove one. Well, you could find the one you want to remove. You could do it that way. Oh, that's awkward. Okay. Yeah, that's a little bit different. So you've got to find the element first. So we have to say auto pointer equals skyline.find h and remove pointer. So you only remove one at a time. Hopefully that works correctly. Oh, erase, not remove. A little nervous. Hoping that works correctly. Hey, oh, hey, sweet. Nice. Wow. No kidding. Wrong answer. No. No. 023253. Okay, 0320 2350. What? So 023 and 253. 023 and 253. 023 and 253. So that looks like the following: 0, 2, 2, 5. So you have 0, 2, 2 events. We add this one and remove this one. And these are both 3. Okay. So this has got to be combined correctly. So I guess my solution doesn't quite work the way I'd like it to. So if you, oh, I see, but if you, oh, because you might have processing these 2 events separately. So what you can do is you can process the same events for the same x coordinate at the same time, and just have a while loop over each event. So we could group the events into based on their x coordinates. We make a map instead of a vector at that point. I don't know if it's worth it to do that. We could just say, just check the previous x value. Yeah, I mean, because you could have, yeah, it's probably better to merge the events that have the same x coordinate together. Thinking how to do that. Yeah, because you could add and remove multiple buildings from the same spot. Well, in here we probably want to. How are we doing on time also? So we're almost there. I think we just about got it, but we just have maybe 5-10 minutes to kind of perform all of those operations in one spot. So you could have kind of a while loop over here of, instead of going through V, you'd have like a, so V could be actually queues of events. And you just process everything in that queue, every event in that queue. And then the queues would be, if they have the same x coordinate, then you'd add it to the same queue. But the tricky thing about that is, like, so you could have like a queue of events you go walk through and add and remove all the buildings. And then at the end here, you check the height. But a queue of events, how do we like, this would be a vector of queues then, of events, rather than a vector of events. I guess what we would say is, the tricky thing at this point would be, how do we link up these events in the same queue, right? So we could do a vector of queues of events, but then each event, how do we know? We could have a, like, just an index for that particular x value into this original vector, right? Just map the index. So a particular value of x, we would get some index. So we're building this, and then we could just dump that map at the end. I think it's something simple like that. I think it's fine. So you could use a queue and use a map as well. A little bit complicated doing it this way, but I think it's fine. So we have queues of events, and then we have an unordered map of just int to int, x coord to queue, something simple like that. And so now we say, we create these events, and we say if x coord to q count of x, or of L. So if not, then we can add. So here's a tricky thing too. Oh, actually, oh man, this is awkward. I mean, you really could have. I'm not doing that. I don't know if we should use a queue. You really could just have the adds and removes for particular heights, and just link them all up to the same x coordinates. So you can use an unordered map and just link up all the, not even the events could just be, excuse me, could just be, these tuples could just be bools and heights, and then they all link up on the same x coordinate. And then you could dump all of these pairs, which would be, you can create, well, then you have a vector of tuples, right? Vector of tuples and a certain integer, a pair of a vector of tuples and an integer. You have an unordered map, and you could dump that into an array and then sort that. I think that's the simplest way to do it. I think it's actually better. So we don't, the events are not really, they're just booleans. Event, and then instead of queues, V is actually going to be pairs. A little bit confusing, but I think this works. So we could do V is going to be pairs of ints and vectors of events. Vector of those things, and then we're going to have an unordered map of ints to vectors of events. And we're going to just say x to events, right? And then now we can say, to make it simple, and just say make a tuple of add building h e1. We're going to say if x to events count of L. If we don't have one, we're going to create one. Insert, or just L, is going to be a new vector of events. And then we're going to say x to events of L, push back E1. There we go. This is kind of the basic structure. And we do the same thing for E2. On the right side, of booleans and int height values to know for each event. Include the event, map the event to array of events associated with a given x coordinate. After mapping all events, sort, insert all of the pairs of arrays of coordinates and arrays of events at the given coordinate into a vector and sort the vector based on the x coordinates of each pair. So that's a little confusing, a little involved. Hopefully it makes some sense. Insert pairs of coordinates and event vectors, event arrays, event vectors into another vector. So we're going to say for const auto reference p in x2 events p.pushback p. So insert all the pairs into our vector and then sort events by the x coordinate. So we can just use auto here. Let's keep it simple. We'll use a comparator too. So this is, yeah, it's taking a while, 40 minutes or so, okay. So it's going to be P1 and P2, and you're actually going to say P1.first is less than P1 2.first. Yeah, we'll just use P1, P2. Okay, by the x coordinate, so now we sort these, sort pairs of events, the event array and coordinate and event array pairs. By the x coordinate, create the multiset, and now add or remove the building from the skyline first. Process all of the events for a given coordinate one at a time in a single batch. So we're going to say x, so it's actually going to be, these are going to be pairs again. Auto p of v. We're going to say for p.second, so we're going to say auto x equals p.second. It's actually going to be const auto. For const event e, reference e in x. Oops. So now, when we process, we're going to process all these events, and we can actually const auto. The event is going to be type and height. We're going to say x is going to be events. So now these are already sorted, these pairs, so we actually don't really care about the first value of the pair, we just care about the second. So each event we're going to process now. And there we go. And the we actually don't really care about the x coordinates anymore. We just use the x coordinates to sort So hopefully this compiles. This is kind of complicated. Okay. So no viable conversion. Oh, yeah. True. X max height. So, oh, we do care actually. It's P dot first. And we just have const int x coord. Hopefully that works now. Hey, there we go. It's so involved. I don't know. I have to run a bunch of different test cases. Maybe we can do. Well, we can actually generate these now with our Python script, right? We can. We can. It's not too bad. All right. So we want. Yeah, it's super easy with the Python script. So we want 100 of these, and we're gonna say. All right, they're gonna have how many? So we're gonna print. It's all be on one line. Use list comprehension all the way through. So for I in range, how many buildings are we gonna have? Buildings 10 to the fourth. So 10 to the fourth, and rand range of 1 to 10 to the fourth buildings, right? Now for each building, we're gonna have 3 values. We're gonna have left, right, and height. Okay, so we're gonna have can we use variables to do this? I don't know if we can. Well, maybe list comprehension isn't the best then. That's okay. Or is a left equals rand range of. Well, we could do the right side first, right? Right is going to be rand range of 1 to 2 raised to the 31st minus 1, and then left is just right minus 1, so it's always less than. And then height is going to be rand range, similar deal, 1 to the 31st minus 1. And then we're going to say ret dot append of right, or left, right, and height. And then we're going to print ret. All right. And we can say sort at the end. So sort, how does Python sorting work? It's been a while. Before we submit our solution, we want to stress test a bit. How to? Sure. A.sort. Okay. How do we use a key? Oh yeah, there we go. Sort by age. So we can do sorted key. There's a sort. Yeah. Excuse me. Oh, you could do key. All right. So key equals, and we can use lambda. Lambda student student 2. That's interesting. So you use a lambda. All right, let's do that. So sort of, so we're going to say ret.sort, and we're going to sort by the left values, I said, right? So how do they do this? Key equals? Yeah, that's it. Just key equals. Yeah, put the lambda right next to it. I was going to say do space. That's probably better. Lambda, and we're going to take x, and how do you specify the lambda? Oh. Oh no, it's just lambda x. Okay, lambda x. And we're going to say x of 0, 1, 2. Not the height, of 0. X of 0. There we go. Okay. So let's Python temp pi. Right, range. Okay. range. Whoa, there we go. Whoa, way. Oh man, okay, we don't have to go crazy. All right, TT. So we got a lot of them. Got a lot going on here. Got 100 test cases here. Whew. Let's try it, see how we do. Whoa, my computer is struggling. Whoa. There we go. This would be O of n log n overall, by the way, as far as I know. And then I think O of n memory as well. Probably could do this with a stack to reduce that n log n portion, maybe. I don't really know, but possibly. Oh man, look at this. This is it's taking a while. Pending. Okay. Whoa. Wow. Hopefully we didn't get one wrong. If we got one wrong, I'll be sad. I'll be sad. Unknown error occurred. Yeah, okay. Let's try again. Nice. Nice. Whoo-wee. Yeah, my test cases are more intense, more extreme than theirs. Oh man. Oh. Non-decreasing order. It just breaks down. It's like it's too much. It's too much. Can't do 100 of these. This is taking a while. Yeah, I think it's timing out. It's too much. All right. Let's go with like 20. Oh, I did this wrong too. Yeah, actually, this is actually incorrect anyway. So left is rand range from 0 to right -1. Yeah. There's that too. TLE. No. Really? What? Huh. Oh no. Timed out. Oh, that's not supposed to happen. Huh. This is taking a while. So asymptotically, this is fine. It's just, I think the issue is that it's just so much extra maneuvering with the maps and whatnot. No. No, it's your lead. Oh, that's upsetting. Oh, that's terrible. Pretty sure we're not supposed to TLE. Pretty sure it's like, all right, let's do like 2. And let's say 10 to the third. Yeah, that's interesting. I don't know, man. I mean, yeah, this is pretty quick. I think we're just TLE because it's just so many. I think it's TLE just because I have so many of them. I don't think it's actually TLEs. I don't know, maybe I'm wrong, but it seems like 6 milliseconds. Yeah, 82 milliseconds. Yeah, that's fine. That's fine. If we go like, so 10 more of these. So let's do like 10 of them. Yeah, I mean, this is reasonable. This is okay. I think we go for it. If there's only one building, what happens if there's only one? Zero, 1, 5. What happens with one building? Oh, okay. 0, 10, 5, 1. Always at least one building. All right, I'm going to submit this. I think we spent enough time on it. Let's see how we do. We might time out. no, we got it. Hey. There we go. All right, as mentioned, there's probably a, this is pretty simple. There's probably, let's sim it again, just see how we do. There's probably a, what do they call that? Like a linear time algorithm that does this. It's probably a lot more efficient than what I have, but that's fine. I think what I did is simple approach. Okay, I'm gonna stop here. So yeah, it would have been nice if I could have solved this faster, but I think I did okay overall. So thank you again for watching. I'll talk to you soon. Have a good rest of your day. I don't know what else to say here. Yeah, we could spend more time pondering like what a like a more actually no, actually no, you could do. You could probably use a frequency map here instead of a no. The problem is that you do need to know, like when you remove the buildings and add the buildings, you do need to know what the new maximum is, and when you remove one of the maximums, you do need to know like what the next maximum is going to be. You maybe could have like I'm trying to think if there's a way to do this. You could maybe have like a stack, and then if you have a larger number, you put it on the stack with the smaller number. But the problem is that when you pop the larger numbers off the stack, the smaller numbers need to be somewhere. like there could still be a smaller number that shows up. So it's definitely easier to just have like a set. You just dump it into the set and hold on to it that way. And then how you handle the events, I think we did that correctly too. I don't know how I would do this otherwise. Really, it's probably about as good as I got. This is about it for me as far as what I would do. Again, there's probably a more clever way to do this, but just it's okay. Don't need to know that. Maybe later we could review it, but for now we'll skip it. So yeah, thanks for watching. Talk to you soon. Have a good rest of your day. I don't know what else to say here. Yeah, just take care. Take care.